Hello students, hope you are learning and practicing well. So this is the third part of our chapter 6 Ganita Manjari NCERT Maths book for grade 9. The chapter is measuring perimeter and area. So in the last video, before closing, we were trying to see if the area of a triangle which we find using the Heron's formula and the area that we find using the half base into height formula, are they giving the same results or not? So this is to see that the Heron formula works as expected. So today we'll see the second example for this. This is with respect to a isosceles triangle. So this is a diagram of an isosceles triangle ABC. The equal sides of the isosceles triangle are of length A. The base is 2B. So this is the perpendicular bisector AD. So this is like of height H, and this is dividing this base into two equal halves, right? So this is with SAS congruency, if you see, or maybe if you see using the right angle hypotenuse side congruency, you will find that these two triangles are congruent, and so the base is divided into two equal halves. Okay, so that is where we have two equal sides AA, and the base is divided by AD into two equal halves B and B. Right? So now, according to Heron's formula, as per Heron's formula, we will first calculate the semi-perimeter. So semi-perimeter will be A plus 2B, which is the base, and this is divided by 2 because this is the semi-perimeter. So this will be divided by 2. This is then equal to 2A plus 2B upon 2. And this is ultimately equal to A plus B. Now, the area is equal to under root of S minus A S minus B and S minus C. So let's substitute the value of S. So what we got for this S is A plus B. So let's substitute the value here. So we will get A plus B, A plus B minus A, and similarly A plus B minus B and A plus B minus, okay, this side is 2B, right? Not B. So A plus B minus A plus B minus, it should be 2B. And A plus B minus, the third side is again A. Right? So let me minus A. And I was just trying to stretch this so that it all comes in a single line. So what I'll do is I'll reduce the size. Yeah. So now it is all in the line. Okay. So if we simplify it, what do we get? You can see this is a plus b. It's already simplified. Then a plus b minus a will be equal to b. The next one, a plus b minus 2b will be a minus b. And then a plus b minus a will again be equal to b. And this is all inside a under root. So what do we see ultimately? This is equal to b comes out, right? And inside we have a square minus b square, because we have a minus b into a plus b from your algebraic identities. If you remember, the value of a plus b into a minus b is a square minus b square. B a square minus b square. And let me put the root symbol at the correct place. So this area is b into under root of a square minus b square. So this is the as per the Heron's formula, right? Now we can see the other thing using the base into height, right? Let me do it here. So as per the base into height formula, the area will be equal to half of base into height. Now height here will be, we can use the Pythagoras theorem. So we will say by Pythagoras theorem, we can say h square is equal to a square, which is the hypotenuse square, minus side square, which is the b square. So it will be or we can say then h is equal to under root of b square minus a square minus b square. Right? So area will be half of base is 2b and height is under root of a square minus b square. So it is the same as this. And this 2 and 2 will cancel. So it will become b into under root of a square minus b square. So what do we see? With both the formulas, we are getting the same result, right? So let's start. Let's take another example. Another example with a right angle triangle. So in this case, we have been given a triangle with sides 3, 4 and 5, right? So now first we will check using the Heron's formula. So let me write here area using Heron's formula. So we'll start with the semi-perimeter. Calculating semi-perimeter, very easy, 3 plus 4 plus 5 by 2. So this is going to be, this is equal to 3 plus 4 is 7, 7 plus 5 is 12. So this is 12 by 2, which is equal to 6. So then we'll calculate the area. So area will be, we'll do under root of S minus A, S minus B and S minus C. So I'm not writing the formula here. I'm just showing the calculation directly. So S is 6 and then S minus A will be 6 minus 3. Then we'll have 6 minus 4 and 6 minus 5. So what will be the answer? This is going to be 6 into, what is 6 minus 3? 3 into 6 minus 4 is 2 into 6 minus 5 is 1. So if you calculate it, you see that it is 6 into 6, which is 36, and the square root of 36 is 6. Okay, so this means the area is 6 square units, right? So let me write square units. You should not forget to write the unit. It's the most important thing. Now let's calculate it using the base into height method. So area, now here we know the seeing it, you may, because these are just the most common Pythagorean triplet. So seeing this itself, you'll be able to make out that it is a right angle triangle. But in case you're not sure, you can just, try out the Pythagoras theorem and see if 5 square is equal to 3 square plus 4 square. So 5 square is 25, 3 square is 9, 4 square is 16. So 16 plus 9, that is equal to 25. So this means it is a Pythagorean triplet. If it is a Pythagorean triplet, this means it is a right angle triangle. If it is a right angle triangle, so this means this 3 will be our 3 will be the height, right? If we are considering base as 4, 3 will be the height. If you consider 3 as the base, 4 will be the height. So here I am considering 4 as the base, so 3 will be the height. So my area will be half of base into height. So here area will be 1 by 2, base is 4, right? 4 into height is 3. So this is half of 12. Half of 12 is 6. So with this also we get that the area is 6 square units. So with all these things, we are able to see that whether we are using Heron's formula or we are using the half base into height formula, we get the same result. It is mainly what you have been given, what you already know, whether you already have the height with you and the base with you, you can very well go and use the half base into height formula. But if you are only given the three sides, you don't know the length of the height, then in that case, you can very well use the Heron's formula to calculate the area. So the next concept is circumcircle or and incircle. Okay. So when we started the chapter on circles in the very first video, I had explained what a circumcircle is. So there we have learned very well in detail how we find out the center of a circle if we have 3 points which have been given to us, three non-collinear points. How do we get the center, and we draw a circle which is passing through all those three non-collinear points. And we also learned in that video that a circle which passes through the three non-collinear points which form a triangle, that circle which is passing through the vertices of the triangle, that is called a circumcircle. So here, if you see A, B, C are three non-collinear points, and this is forming a triangle ABC, and the circle with radius capital R. Okay, so the circle with radius capital R, this is passing through all these 3 points, all the 3 vertices of the triangle ABC, right? All the vertices of triangle ABC, right? So this such a circle which passes through the 3 vertices of the triangle, this is called a circumcircle. Okay. Then what is incircle? So if we see a small circle here, the small circle which is inside the triangle, right? So this circle, the special property is that this circle fits completely inside the triangle, and its sides, the circle, touches each of the sides of the triangle, and it touches the sides at exactly one point. So basically AC, BC or AB are tangents to the circle. Tangent is a line which touches a circle at just one point. Okay, so this incircle is a circle that fits completely inside the triangle. Here, the radius of this incircle is small r. Okay, and here, I've written circle R, but basically it is the circle passing through all the vertices of triangle ABC, and it is called circumcircle. R is the radius of the circumcircle. So we had also learned, right, that there is a unique circle passing through 3 non-collinear points. Now 3 non-collinear points form a triangle. So there is a unique circle passing through the vertices of a triangle, and that unique circle is called the circumcircle. Now there is a very interesting formula for the area of this triangle ABC. So the proof of this formula you will be learning in grade 10. So I will not cover it in this video, but only the formulas you can see and remember. Okay, so area of the triangle ABC here in terms of this circle will be giving. Okay, so and this sides of this triangle, this is A, length is A, this is B, and this length is C. So this overlapping, let me write it here. This length is C. So when we write this area of the triangle ABC in terms of the circumcircle, we write it as ABC upon 4R. This capital R is the radius of the circumcircle. If we write it in the terms of incircle, we can write it as A plus B plus C into R. This R is the radius of the incircle. Okay, this R is the radius of circumcircle, and here this R is the radius of the incircle. So these two are the formula for the area of the triangle in terms of the radius of circumcircle or radius of incircle. Okay, so with this we have covered everything about the area of a triangle. Okay, so with Heron's formula, we learned that we are given the three sides of the triangle, the length of the three sides of the triangle. We can calculate the area of the triangle. But what about the polygons? If we are given all the four sides of the polygon, are we able to calculate the area using the four sides? For example, if we have this square and we have been given this square is of side 3, 3, 3, 3. So it is easy. We know that for square, the area will be 9 square units because it is side square, right? But what about a parallelogram? For parallelogram, what did we learn about the area? How do we calculate it? It is base into height. Now, if we are given the sides, are we able to calculate it? If suppose this parallelogram has been made with all the sides 3 units, is it the same as square? Is it going to be 9 square units? No, it is not. It is 8.01 square units. Now, similarly, if you are given a rhombus with all sides 3, 3, 3, 3, is it going to be the same as square? Again, no. Its area will be different. So for rhombus, we calculate it using the length of its diagonals. Similarly, for parallelogram, we calculate it as base into height. So we need to know some geometric property apart from the sides to calculate the area, right? Now, Brahmaputra came up with a very interesting way. So he mentioned, so as you say in the topic I have already written, right? Cyclic polygon. So what he said is, if the polygon is a cyclic polygon, which means all the four vertices of the polygon fall on the circle, or a circle passes through all the four vertices of the polygon, then we have a way to calculate the area of the polygon given its four sides. So what is that? So here we have a circle, okay, and we have a cyclic polygon ABCD. Okay, so I'll write it here. We have a cyclic polygon ABCD with sides small a, small b, small c, and small d. Then in that case, area of the cyclic polygon is equal to, and this will, okay, so before we calculate it, I'll show how to calculate. So first is we define the semi-perimeter. Just like in Heron's formula, we used to calculate the semi-perimeter. So the perimeter will be A plus B plus C plus D. See the first video in this chapter to understand, in case you have forgotten what perimeter is. You can just see that video and revise it. But I hope you already remember it because you have learned it in your lower grades. So this is our semi-perimeter, A plus B plus C plus D upon 2, right? Semi means half. So it is half of the perimeter. So now the area will be, it looks somewhat similar to the Heron's formula, the slight difference. Now this one is called, semi-perimeter is called S. As we did in the Heron's formula, we will calculate this semi-perimeter as S. And then the area will be S minus A, S minus B, S minus C, and S minus D. So in case of Heron's formula, we started with S. S into S minus A, S minus B, S minus C. Here it is slightly different. S minus A, S minus B, S minus C, S minus D. Because there are 4 sides. And this is the area of this cyclic polygon. Okay. So just like we learned in the case of Heron's formula, we learned what the Heron's formula is, and then we try to validate it by comparing it with the areas that we got from the base into height, the half of base into height formula. So similarly, we will try to compare it to the different formulas that we already know about the area of a polygon and compare it with what we get when we apply the Brahmaputra's formula. So that was Heron's formula. This is Brahmaputra's formula. Sorry, not Brahmaputra, it was Brahmagupta. So Brahmaputra is a river and we learned in geography a lot about it. So that is why it came from my mouth as Brahmaputra instead of Brahmagupta. But actually the scientist's name is Brahmagupta. Okay, so we'll start with area of a rectangle. So rectangle, we know already it is a cyclic polygon. So that is why we have taken rectangle to test this. Okay, so area of rectangle, here we have been given length is A and breadth is B. Area is length into width. Simple. A into B square units. Now let's apply Brahmagupta's formula, not Brahmaputra's. Okay, so for that we need to first calculate the semi-perimeter. So semi-perimeter will be A plus B plus A plus B upon 2. So this is going to give me 2A plus 2B upon 2, which is A plus B, right? Or to, give you a clearer picture, this is 2A plus 2B upon 2, which is equal to A plus B. Because we'll take the 2 out. 2 is common for both first and second terms. 2 is taken out. A plus B. 2 into A plus B upon 2. The 2 divided by 2 is 1. So ultimately we are left with A plus B. Now we calculate the area using the Brahmaputra's formula. Brahmagupta's formula, my God. Okay, so this is going to be S minus A. S is A plus B minus A. The second term will be A plus B, because S is A plus B minus B. Now the third side is again A. So this is going to be A plus B minus A. And the fourth side is again B. So it is going to be A plus B minus B. And this is all under a square root. So let me extend this. This is all under this square root. So now we simplify it. It is going to be A is cancelled in the first term. So it is B into A plus B minus B is going to be A. Then A plus B minus A is going to be B. And A plus B minus B is going to be A. So ultimately, it is going to be, take out, we have A square into B square. So we are taking an under root. So this is going to be A into B. AB square units. So we saw here, right? AB square units. And we see here AB square units. So with Brahmagupta's formula also, we got the same answer. Now let's take another example. The next case is the case of an isosceles trapezium. Now you must be remembering what isosceles trapezium is. So isosceles trapezium is a trapezium where the non-parallel sides of the trapezium are equal in length. So here is a trapezium we made. So here the two parallel sides are of length 2A and 2B, and the non-parallel sides are of length C and C, because it is an isosceles trapezium. Both the non-parallel sides are of length C. So here we start with the Brahmagupta's formula first. Gupta's formula will take. So for that, what we'll do is first calculate the semi-perimeter. So semi-perimeter will be 2A plus 2B plus C, which is 2C, and that is divided by 2, because it is a semi-perimeter, right? So this makes it A plus B plus C. So this is the semi-perimeter. And then we go ahead with calculating the square root. Square root of S minus A, S minus B, S minus C, and S minus D, the four sides. Right? So here our area will be under root of, now here S is A plus B plus C. So we do a S minus A. So let's take the first side. This is 2A. Now let's do a S minus B. It's the second side. So here S is A plus C minus 2B. And then the two other sides are C and C. So A plus B plus C minus C. A plus B plus C minus C. So we have taken all the four sides. Now let's simplify this. When we simplify it, it will come as A plus B plus C minus 2A. That will make it b plus c minus a. The next one is a plus b plus c minus 2b. So this makes it a minus b plus c. Right? The third and fourth one are same, a plus b plus c minus c. This makes it a plus b and a plus b. Now this is a simple one, a plus b, a plus b. We are multiplying twice, so we can just straight away take it out of the square root, because here inside the square root we are multiplying it twice. This means it is a square, and we can take this out. So a plus b, and then we have under root of b plus c minus a minus a, and we have a minus b plus c. Now if you look closely at these two, what you'll see is c is positive in both of them, and then we have b minus a in the first term. In the second is a minus b, or maybe you can write it as minus of b minus a, right? So what do we see here? A plus b is out, and then we can write it as the first one as c plus, maybe I'll change the brackets so that we are clear here, c plus b minus a, that is the first term, and then you can see c minus b minus a. See, c minus b plus, it will, if we open this bracket, it will become c minus b plus a, right? Which is what the second term is, c minus b plus a. Why we have written in this form? Because we can use the algebraic identity to simplify it further. Which algebraic identity it reminds you of? Can you think? It's a plus b into a minus b. A plus b into a minus b is a square minus b square, right? So then we can write it in the form of, here the first term is c. So we'll write it as c square c square minus b minus a whole square, right? We can write in this form. So this is the area of this trapezium, square units. Now what I'll do is, I'll calculate the area using the usual formula that we know for the trapezium. What is the usual formula which you have learned in your 8th grade? Area of trapezium is half of the sum of parallel sides. So sum of parallel sides is 2a and 2b into the height of the trapezium, right? Now height is something which we don't know. As I said, we have been given only the length of the 4 sides. So in this case, but we know here this h is perpendicular, right? And we can apply the Pythagoras theorem. Now this is an isosceles trapezium. So what this means is, if we are drawing this two perpendiculars, then the length, this length is equal to 2a, same as this, right? Because this is forming a rectangle. What about the other two? What about this and this. These two are equal in length. How do I know it's equal in length? See, if we are applying this, if we are seeing this, this is c square minus h square, this length. And similarly, this length is also, this is because this is also h. So this length will be under root of c square minus h square. And here also it is under root of c square minus h square. So basically these both lengths are both equal. Okay, so now this is equal to 2a and this is then equal to 2b and plus 2 of some value, right? 2 of some value, meaning, for example, let me assume this is x, okay? And this is again, because this is equal to that, this is equal to x. So in that case, 2b will be equal to 2a plus 2x, or you can write it as b is equal to a plus x, or you can write, because x is the unknown here and we have already been given the lengths of b and a, so we can write it in terms of a and b, that x is equal to b minus a. Now if we have to calculate h, now again Pythagoras theorem, so we know that c square is equal to h square plus x square, right? By the Pythagoras theorem. So this means if we have to write it in form of, so this will be c square is equal to h square plus b minus a whole square, because we have found here that x is equal to b minus a. So what we need to find out here is we need to find out h. So we'll do h square is equal to c square minus b minus a whole square, or h will be equal to c square minus b minus a whole square and the under root. Where do I get the symbol? Oh. So h is this. Now I've written the formula there, right? So then in this case, area will be 1 by 2 so some problem. Yeah, 1 by 2 of 2a plus 2b and into h. So h will be this. So h is going to be for some reason not able to select it. So copy it. Let's see if I'm able to copy. Yes, I was able to copy. Okay, so 2 and 2 cancel here. This, if I try to write this way, by 2 rather than the slanting one, it will be give a clearer picture, right? So let's move it here. So this is then half this 2 and these 2 cancel out, because this can be written as twice of a plus b. So 2 divided by 2 is equal to 1. So then this leaves us with a plus b, and the second part, which is under root of c square minus b minus a whole square. So here also we can very well see that the area calculated for this isosceles triangle with both the methods, the formula, applying the formula of half of sum of the parallel sides into the height. This is giving the same answer as what we got with the Brahmagupta's formula. Okay, so this proves that both the formulas give the same result. So with this, we will end this part 3 of the chapter, and we'll meet again for part 4, and we'll learn a lot of new things about the area.